Welcome back, students. Today in this session we are going to see some of the very important questions that are associated with electricity. So, I will show you what are the important topics under which the questions could be asked and what are the important tricks that you have to follow to solve it in a better way. So, the first question goes like, a current of 10 ampere flows through a conductor for 2 minutes. Okay. So, they have just given a data saying that there is a current of 10 amperes flowing through a conductor for 2 minutes. Now, calculate the amount of the charge passing through a unit area of cross section of a conductor. First, you have to tell me how many charges are going to go through an area, and in the second case, the charge which is an electron has this much charge, okay, 1.6 into 10 power 19 coulomb of charge. Then calculate the total number of electrons flowing. Okay, the first case, you have to find the quantities. Okay, in the first case you have to find the quantity, in the second case you have to find the number. Okay, so let me put it in a straight fashion that I is 10 amperes given 10 amperes, okay, and the time here is 2 minutes, which is 120 seconds. So, as I have already said, in the first scenario they are asking for the amount of charge. So, I is equal to Q by T it is. Q is the one which they are asking us to find. So, Q is equal to I into T. Q is equal to I into T. So, what is I here? I is nothing but 10 and the time is 2 minutes, which is 120 seconds. So, totally the amount of charge that is going to flow for 2 minutes is 1200 coulombs. 1200 coulomb it is. So, this is the amount of charge that is going to flow through. So, now in the second case we are looking to find the number of charges that are going to go. Okay, so how to find the number of charge? It is again straightforward. Q is the total charge and each and every individual charge is going to have 1.6 into 10 power minus 19 coulombs. So, how many such charges should join together to give you this 1200 coulomb? So, the formula is N into E. Q is equal to N into E. So, 1200 is equal to N into 1.6 into 10 power minus 19. So, to find N, you have to bring everything to the denominator, where N is equal to 1200 divided by 1.6 into 10 power minus 19. So, N over here is nothing but we can easily calculate that it is 7.5 into 10 power 21. 7.5 into 10 power 21 such charges will flow. Okay, so here they are talking about electron. Okay, so 7.5 into 10 power 21 electron has to flow for 2 minutes to produce this much amount of charge is what we have found. So, for the first subdivision 1200 coulomb is the answer, and for the second subdivision it is 7.5 into 10 power 21. Yes. Likewise, the second question is a study of VI graph. VI graph means the graph is drawn between the voltage and current for a resistor as shown in the figure, and prepare a tabular column showing the value of I in amperes corresponding to 4 different values of V. Okay. Find the value of current for V is equal to 10 volt, and how can we determine the resistance of the resistor from this graph? So now we have to basically form a tabular column, okay, to show the value of I. Okay, so it's actually straightforward because this is a linear curve, it's a straight line curve. So for that they are asking you to write the current for all the given voltages. So I am going to prepare a small tabular column. Here this is V and this is I. So in V we will have 4 quantities, 2, 4, 6, 8, and we will have corresponding amount of current that is going to flow through it, which is 1 ampere, 2 ampere, 3 amperes and 4 amperes. Okay, V is in terms of volt and I is in terms of ampere, do not forget. So this is the tabular column. So next they are asking us to find the value of current for 10 volt. Okay, for 10 volt. See, here you would have had 10. How do I say that? Because y-axis is in the scale of 2 units. So this should be definitely 10. Again, if I draw a dotted line like this and if I drop a perpendicular, I can see that it meets 5. So for 10 volt, it would have been 5 amperes. Okay, it's pretty much straightforward. So this is the answer for your first question. Next, how can we determine the resistance of the resistor from the graph? It's very easy actually. We have to find the slope. See, slope formula is nothing but del y by del x. Okay, change along the y axis by change along the x axis. So m is equal to y by x it is. So what do we have along y? We have v. What do we have along x? It is I. That will give you the resistance. Clear? That will give you the resistance. So likewise, we are searching for the resistance here and we know that the resistance is constant. So you can take any set of values to calculate the resistance. So capital R is the one which we want. I am going to take the first set of quantity on this one. Look, I am going to take this and I am going to calculate the resistance for this set. 2, 1. 2, 1. So along y you have 2, along x you have 1. So the resistance is 2 ohms. Again, here we have 4 and we have 2. So 4 by 2 is 2 ohms. See, for all the set of quantities you will get the same amount of resistance, which is 2 ohms. So this is the answer for the second set of question. So this is how it is done. So now we move to the next question. Here a cylindrical conductor of length L and uniform area of cross section A has resistance capital R. The area of cross section of another conductor of same material and same resistance but of length 2L is. So here we have two set of datas. I call this type of question as the dual data question because we have two set of datas. From that they are asking us to conclude something. See, first 1, 2. A cylindrical conductor has a length L and the area of cross section A, okay, and the resistance in that case is R. So these are the quantities that is given for the first conductor. Then the area of cross section of the another material and same resistance but the length is doubled. what happens? The area of cross section and the material for another conductor is same, okay, resistance and area of cross section, but length is being doubled. So 2L AR. Okay, so in this case, what are we supposed to find? We are supposed to find the resistance. Okay, just a minute. For the second material, the area of cross section is same, but the length is doubled. And same material, so they are asking us to find the resistance. Okay, I am not saying the resistance is same. The resistance is the one which we are supposed to find. So what I will do is, I will frame two equations based on two datas. According to first data, R is equal to rho into L by A. In the second data, R prime, the resistance that we have to find, since it's the same material, the resistivity will also be same, where the length was doubled, whereas the area remains the same. Now I will just divide both and I will get the answer. This is the general procedure to solve any dual data problem. If you are provided with two set of datas, okay, write two equations accordingly and divide them. So everything gets cancelled except R. So R prime is equal to, what happens? This 2 gets cross multiplied there. So R prime is equal to 2 times R. We already know this. If the length of any material is going to increase, definitely the resistance of that material will also increase. That's very prominently known from this calculation. So now we move to the next question. See, this is a numerical problem. Calculate the resistance of a metal wire of length 2 meters and the area of cross section is 1.55 into 10 power minus 6 meters squared if the resistivity of the material is this. Okay, it's actually pretty straightforward. They are asking us to find the resistance, whereas the resistivity, length and area of the material is given. So capital R is equal to, what is rho here? 2.8 into 10 power minus 8 into, what's the length of the material? It is 2 divided by, what is the area of cross section? It is 1.55 into 10 power minus 6. 1.55 into 10 power minus 6. So now all we have to do is general multiplication and division to get to the answer. So capital R is equal to 5.6 into 10 power minus 2 divided by 1.55. 1.55. So now the answer for this question is just the division of 5.6 by 1.55. If you are not so good at dividing the decimal terms, what I strongly recommend you is to approximate everything. Okay, if you could approximate everything, you will directly get into the answer. So I will not show you how the division is being done here. Instead, I will directly write the answer, which is 3.6 into 10 power minus 2 ohms. 3.6 into 10 power minus 2 ohms. Otherwise, it is 0.036 ohms. Both are same. Both are same. So this is how it is done. See, some questions could be directly solved. This is one among them. We move to the next one. Here, a copper wire has a diameter of 0.5 millimeter and the resistivity of 1.6 into 10 power minus 8 ohm meter. Calculate the length of this wire to make it resistance of 100 ohms, how much does the resistance change if the diameter is doubled without changing its length? Now what I am going to do is, I am trying to maintain the resistance, but I am allowed to double only the diameter, but length is not allowed to double. So in that case, what am I supposed to do? How much does the resistance change? Yes. So here it is going to be simple again. Look, the diameter D is equal to 0.5 millimeter it is, and the resistivity rho is 1.6 into 10 power minus 8 ohm meter. Okay, and I have to get a resistance of 100 ohms. Okay, so for this I am going to calculate the length. You know the formula, it is R is equal to rho into L by A it is. So L is equal to R into A by rho it is. I will take all the quantities and I will try to plug it in. But before I could do that, I need to calculate the area. So wire is typically considered to be a cylinder. So the cross section area of a cylinder is the area of a circle, which is pi into r squared. Pi into r squared, where area is equal to pi into 0.25 into 10 power minus 3 into 10 power minus 3. I will convert millimeters to meters because I have meters in here. Okay. So 3.14 into 0.25 into 10 power minus 3. The area A. The area A of this is nothing but 1.9 into 10 power minus 7. 1.9 into 10 power minus 7 meter squared. This is the area of a cross section area of a conductor. This is the cross section area of a conductor. So now I will take this and I will plug it in. L is equal to 100 into 1.9 into 10 power minus 7 divided by the resistivity of it is 1.6 into 10 power minus 8. So the length could be directly calculated just by multiplication and division. I am not going to show you how it works. The answer that you will be getting is 1200 meters it is. So that is the answer that you will be getting for this, 1200 meters. So if you have a wire of 1200 meters, you will have a resistance of 100 ohms in this particular condition. So now I will show you how the second part of this problem is done. In the second part of the problem, how much does the resistance change? What will be the resistance if you double the diameter without changing the length? See, what I will do is, I will first find how much my area is going to change if I double the diameter. Okay, so diameter is nothing but 2 times the radius. Okay, so radius will be d by 2. See, A is equal to pi into, instead of r I am going to put d square by 4 it is. D squared by 4 it is. Now that is my typical area when the diameter was d. Now I am going to double the diameter. If I am going to double the diameter, my area will also increase by 4. My area will increase by 4 if my diameter is going to get doubled. So now what I will do is, I will see how much my resistance will increase if my area increases by 4 times. So, this is the basic formula that we will be using. So, R prime is equal to 4, R prime is equal to R by 4 it is. Why my resistance is getting decreased if the area increases? Because resistance is inversely proportional to area, and if your area increases by 4 times, your resistance decreases by 4 times. So, this was the initial length. This was the initial length and this was the resistance that we had. Okay, since I am doubling the diameter, my resistance reducing by 4. So, 100 by 4 is 25, is basically 25 ohms. So, this will be the resistance of my wire if my diameter is going to change. So, these are the different ways and different techniques with which we keep solving questions from electricity. So, with this we come to the end of this session. In the next session, I will be showing you few more other problems which could be solved. Thank you.